Morning,
Thank
everyone.
you. Yes.
In any place on this nice planet or Earth, but we are interested, as Nora mentioned, in the moon. Actually, the moon is our neighbor, and there is a growing number of robotic expeditions. Probably in 1 month or something like that, the first human mission circling around the moon will start also after many, many years. You know, the last people on the moon were 1972, the Apollo 17 mission. NASA is trying to put boots on the moon surface as well. And this is actually a kind of a new space race between mostly China and the US. But behind before the human flights, there is a lot of robotic flights, and the goal is actually not only to be the first again. Putting humans on the surface on the moon, but setting up a permanent basis on the moon and looking around what can we use in situ. That means on the moon. So if we go somewhere, it's always very useful not having to bring everything with us, what we need, but take a look what can we use really on site. And this is our business actually. So one of the major potential resources on the moon is water ice. You might be surprised that the moon has water, but this is growing evidence that it's enough water ice in the upper 1 meter of the lunar soil. And if we can access this and can exploit it, that of course, the first thing is that we can provide water and maybe oxygen for the humans. But the major stuff is, you might remember from your secondary school, that actually, maybe I think in Hungary we had it in the 7th or 8th class, just to separate water with electrolysis into hydrogen and oxygen, and then make a drink. That means that use the hydrogen as it's a little bomb. But if you can make hydrogen and oxygen, this is the best chemical propulsion material what we can use for rockets. And this is, of course, something very important. But we don't know exactly where enough water ice is. And this is where we are in play. We have developed a couple of years ago our little Puli lunar water snooper. Most people know Puli is a dog breed, so that's the reason we called it Snooper. And this is a miniaturized, ruggedized neutron spectrometer, which is able to detect or to show the amount of hydrogen and so water actually in the lunar surface. And we have the so-called flight heritage. Our first lunar snooper, water snooper, landed on the moon last year on Intuitive Machines. This is a Houston-based company mission. We collected some data. Unfortunately, the landing was not quite successful, so we had only a short time for collecting data. But anyway, we have the so-called TRL9, Technological Readiness Level 9, which is flight proven. So our snooper is really, I think, in a good position to go further. But what you need to detect water ice on the surface, you need to move such an instrument around. So that means we will need a moon rover actually going around, and this is where we are looking for the help of the community and raising money. We had also developed a small, lightweight, very simple rover with unique mobility capabilities. This is the Puli rover. You can see in the background two of them. We have been in several so-called lunar analog sites here on Earth to test it. How does it work? But we need, of course, a little bit money to set up the moon-ready version. It's mostly the electronics and then several other stuff, and to organize the missions. We have contact and highest level contact to all of the US and Japan-based companies who are able to set up a lunar mission. This is the way NASA is doing it as well. So we can organize such missions, and we can go to the moon and look around for for water ice. On the other side, the rover will be able to host other payloads, and this is actually the second step of the business model what we are pursuing. If I will get to the moon. I have to pay so roughly $1.5 million per kilogram to get to the moon. This is the price what the companies charge. But if you something want to move around the moon, it has also a price. And this is roughly $4.5 million per kilogram. So it has easy calculation. So if there is a payload capacity of 3 kilogram, which we can sell for a 10 kilogram class of rover, then I will have to pay, let me put in that way, 10 million or 12 million, depending on the price. And I can charge $13.5 million on one mission. So this is actually one of our business advantage that we can organize these missions. And again, we are in a very good position to get that missions. If we succeed, probably end of this year or early next year with finishing the rover, then we can already in the meantime work on the mission organization. And we are pretty positive about one mission per year. There is a need for that because water ice is suspected to be in roughly 6,000 square kilometer area. But we don't have this very good surface information. So we will need a lot of uh, so-called prospecting missions just to see where it is. And for this, you have to go to many places. You have to make many measurements. So we don't fear also concurrency for maybe other small rovers, but there is place for other things as well, and there is definitely place for the Puli rover in the next 5 to 8 years. So this is roughly our stuff where we are. Our next mission will be actually in July this year when everything goes well. The flight unit is already delivered. It will go again to the lunar South Pole region, and we are working at the moment with three US teams to set up a mission where they want to have our Puli water snooper, and we have a European company and a Belgian company. They want the snooper as well. This is an intended mission in 28. So that's actually the business is in good hands, and we hope that we can also go further. And we have already our campaign on Tokyo Portal, the pre-registration phase, and Nora can tell you that latest numbers. I think there is a really good interest in our mission.